Hello everyone, my name is Shyam Manavat and I welcome all of you to the lecture on logarithm. In this video we will understand the principle of log, rules related to logs and some questions on that. So it's a concept builder videos guys. So people who are beginner in log, let's get started. So here you can see on the blackboard that the principle of log, I call it principle of log, that is a raised to x equal to b. This is all the rules and the properties of log work on this basic principle of log, which says a raised to x is equal to b. Then in that case log b base a equal to x. Yes. So how do we, okay, I'll give you an example to understand. Before that, you need to learn how to read this. People sometimes read this as log AB. It's not log AB, it's log B and base A. Log B base A. Log B base A. Yeah, that's how you should read it. So here what am I trying to say here is a raised to x is equal to b. That means if you have any number, let's say 2. Now 2 to the power 3 is what? 8, correct? 2 cube is 8. In that case, you have log b. What is b? The value after applying the power, after simplifying the power. And this base will come as base of log. So if you apply it over here, what you get here? That is equal to x. Okay. So what you get here? Log of what? B. After simplification of the power, what you get is b. Here what you are getting? 8. So log of 8, and what is the base here? Base of the power is what? 2. So base of the log become what? 2. That is equal to the power here. That is equal to 3. Did you understand? Let's try one more time. Let's try one more time. 3 raised to 4 is 81. 3 to the power 4 is 81, right? Now if you want to write this in terms of log, how do we write it? Log of the outcome after simplification of the power, that is 81, and here this base will come as it is, equal to 4. Understood? Okay, let's do the other way around. Let me ask you one question. Okay, let me ask you one question. So if I write log of 216 base 6, what should be the outcome of this? What should be the value of log 216 base 6? If you have done the homework, which I keep on repeating in almost every lecture, the homework is what? You should learn table till 20, tables till 20, squares till 25 and cubes till 10. So if you have learned this, then I hope you remember that 6 cube is 216, correct? So here the question is log 216 base 6. So you need to tell me what power of 6 will get you 216. So what power of 6 can get you 216? It's 3, right? 6 cube is 216, correct? So the value should be 3 here. The value should be 3 here. Or we can also write this in terms of power, that is 6 to the power 3 equal to 216. Are you learning? Are you learning? If not, then please write in the comment box. I will be happy to give more example and make it simpler for you. Let's try one more question. If I say log of 64 base 8. Now, what power of 8 will you apply to get 64? Yes, of course, it's 2. 8 square is 64, right? 8 square is 64, right? So we can say log 64 base 8 is 2. So 8 square is equal to 64. That's why we can say it's 2. Did you understand the principle of log? Okay. Now, and see, it's not necessary that you will always have the integer power or natural number power. Sorry, the integer power. You may also have decimal. Yeah. So That's quite possible. Now let's see some rules of log. Log of 0 base a, how do I read it? Log of 0 base a is not defined. You know what? If I say log of 0 base a equal to a number which we need to find out, we need some outcome of this. Now, any number to the power any other number can never get you 0. Think about it. That's only possible when a is also 0. That's only possible when a is also 0. Did you understand? A raised to x is equal to 0. Yeah, that is possible only when base is 0, a is 0, right? And for log, base is never equal to 0. Yeah, keep this in mind. Okay. Let's see next. What do we have here? Log of 1 base a equal to 0. Okay, that is with the property of what? With the property of what? If you know the property of indices, any number to the power 0 will give you 1. Any number, 2, 3, 5, 10, 100. If power is 0, then it will get you option, it will get you output 1. Okay, so that's how we say log of 1 base a is 0. Fine. This is what you need to remember. Now, log of a base a. What power of a can get you equal to a? Obviously 1. Yeah, this is equal to value. This is always power, right? This is what we understood from the principle of log. So that is 1, correct? So here log of a base a equal to 1. Log of 2 base 2 is what? 1. Log of 10 base 10 is equal to what? 1. Yeah, remember this. Third one is log of m base a and log of n base a. If it is addition, then the outcome is log of m into n equal to m into n and then base a. Yeah, so if it is an addition, then we can, if we take the log at once, then we can't say common. It's not in multiplication. See, log m base a is not log into m. It's not multiplication, so we can't take that common that way. So if it is plus, then if we simplify it further, the values are multiplied, or other way around. If it is multiplied, log, for example, log of say 3 into 5 base 10, that can be written as what? Log of 3 base 10 plus log of 5 base 10. Clear? So if it is an addition, so it's vice versa is also correct. Similarly, if we have negative sign between the logs, where keep in mind the base should be same, all right? Yeah, base should be same. Only then you can write this way. If base is different, then you cannot. We need to make the base equal, then we can simplify further. So we will learn how to make base same. Here, if it is in subtraction, what do? Log of m base a minus log of n base a equal to log of m by a. So if it is plus, then the numbers will be multiplied. If it is minus, then numbers are divided. Okay, so let's take example. Let's say log of 3 base a minus, okay, instead of base a, let's say base 10 minus log of 5 base 10. That will get you what? Log of 3 by 5, and because base is same, base 10. Yeah, we can also say other way around, as in if I say log of 7 base 12, sorry, log of 7 by 12 base 10, I can write this as log of 7 base 10 minus log of 12 base 10. Clear? Okay. So this is rule number 4. Rule number 5, here we have, if you get any power of the number which is inside the log, then that power will come as multiplication of log. Yeah, let's take one example. If I say log of 5 square base 10. Log of what? 5 square. So it is not equal to, see, first you should understand, this is not equal to log of 5 base 10 whole square. That is different. This is different. This is different. Okay. As of now, we are talking about what? The number inside the log that is having some power. So this power will come as multiplication in front of the log. So the outcome is what? 2 log 5 base 10. Yes, 2 into this can be read as 2 multiplied by log 5 base 10. Okay. Yeah, let's try one more. If I say log of say anything, 7 cube base 10. So we can say this is what? This power 3 will come as multiplication of log. So it's 3 into log of 7 base 10. Alright, this is the fifth rule. Next one, seventh one. In case you have power of the base, then that will come as denominator of log. Let me give you one example. Let's say if I say log of 11 base 2 cube. Yeah, so this 2 base having a power, that's different from the number is having the power. Yeah, this number inside the log that has power, that's different. Yeah, so if you have some power of the base, then this cube, this power cube which is of the base will come as the denominator. That means log of 11 base 2 as it is, and this 3 will come over here. Okay, let's try once again a different number. So log of 15 base 3 square, log of 15 base 3 square. That's how we should read this. So this will get you what? Log of 15 base 3, and this power of base will come as denominator. Is that clear? Yeah, this is rule number 7. Next, 8. Yeah, if you interchange the base and the number with log, that means if it is log 3 base 2 can be written as 1 upon log interchange the base and the value. So log 2 base 3. If you want to interchange the value and base, that's how it works. It becomes 1 upon. Understood? One more example. Log of 7 base 5, that can be written as 1 upon log of 5 base 7. Okay? Yes. Next, property number 9. If you want to introduce a new base in log, if you want to introduce a new base with log to simplify it further, then you can write it like log of b base a is equal to log of b. Let me correct this one. This is not correct. Log of b by log of a, log of b by log of a. Did you understand? The number b as it is and a here as it is, and then you can introduce a new base to this log. It is possible. So if you want to do it in this way, that's how you get. Okay, let's take one example. Suppose if I have log of 36 and base 3. Okay, no, log of, let me take something else. Say log of 72, and here base is 36, let's say. Okay, so I can simplify this as log of 72 by log of 36, and whichever base I want to utilize to simplify this, I can take base 6 here. Okay, that will be easy because you can see 6 square is 36, so I can write this as 2 as it directly, and this I can simplify as log 72 as 36 into 2, and further simplification is possible. So if I want to have any other base than what is given to us here in the question, then I can use this property. Yeah. Let's take one more example. Say log of anything, let's say 11 base 5. I can write this as log of 11 by log of 5, and I can use any base which I want to convert in. Okay, so whenever you want to introduce any new base to the log, you can apply this property. I know it might be sounding Greek to you, but don't worry, when we solve the question you will understand what are we talking about. And here this property is interesting. Please focus here. Let me write this again. It's a to the power log m base a. So log is in power. Now the base of log and base of this term is same. Base of log and base of this term is same. In that case, this m can be written directly here. Okay. Should I repeat this? Say 2 to the power log 216 base 2. So this 2 and this 2 is same. In that case, I can write this output of this term as 216 directly. Yeah, did you understand this 10th property? Okay, now let's apply these properties solving some questions. Easy question. It's a concept builder video. I hope you understand. Okay, fine. The first question here I have is log 27 base 3. If you apply the principle of log, you know 3 cube is 27, right? So what should be the output of this? What power of 3 can get you 27? 3, right? So the outcome should be, the answer should be 3 here. Are you understanding this? Yeah, let's try once again. Now see, here I got 27 and 81, which has no relation. See, 81 to the power anything is 27. We can't directly say, it is possible, the power will be in fraction, but directly finding this is difficult. So I will make it simple. What do? I know that 27 is nothing but 3 cube and 81 is nothing but what? 3 raised to 4. So what do we do in that case? We have base 3 which should be common between them. Yeah, which is common between them. So to introduce a new base, I will write log 27 base 81 as log 27, yeah, log 27 by log 81, and I can write I can introduce new base. I can write 10 also, I can write 5 also, but I should use, definitely I want to solve this question, right? So I should use a base which we can utilize further, like base 3. So I know that log 27 base 3, you get this when you have power 3 of the base, right? So the output of log 27 base 3, we have solved this in question number 1. That should be what? 3. And what power of 3 can get you 81? What power of 3 can get you 81? 4, right? So this is 4. Yeah, so that's how you can simplify. So did you understand when do you require to introduce a new base and how to do it? Yes? Okay. Let's look at the next question. Next question here. This is log, let me write the question again, log 1 by 216. This is more representable than, I did not have choice to write in fraction here. So are you okay with this? Yes? All right. Okay. Now what do we do? First, there are many ways to solve this. There are many ways to solve it. You can say 1 upon 216 is nothing but 216 raised to minus 1. Yeah, 1 upon a to the a raised to n, that's a property of indices. That can be written as what? A to the power minus n. You can note this property of indices. We are going to discuss this property of indices here in this chapter. Okay. As of now, come back. 1 upon a raised to n can be written as a. So we can use this. So what happened when I use this? 36, and then it will become 216 raised to, here 216 is raised to what? 1. So I have what? Minus 1 here, right? Okay. Then further I can apply the rule of log, the property of log, which says what? Log m raised to n base a can be written as what? Log n will go in multiplication, yeah, so n log m base a, right? So this will be minus of log 216 base 36. Okay. Now here I have one value which is common between 36 and 216. What is that? 36 is 6 square and 216 is 6 cube. Okay. So I need base 6. I need to introduce base 6 here. So negative sign as it is, I can write this as log of 216 by log of 36. Now I want to introduce a new base here, right? Then I write the new base here as 6 and 6. This new base can be anything, as I am repeating this new base can be anything. It should be only that this base should be useful to you to simplify it further. Don't make it complicated by introducing some other base. Like suppose if I use base 2 here, if I introduce base 2 here, that will again make it complicated. Yes. So use this property to simplify further. Now this is minus of, come on, 216. What power of 6 can get you 216? That's 3. What power of 6 can get you 36? That's 2. Yeah. So the answer is what? Minus 3 by 2. Easy, simple. Concept builder videos guide called concept builder. This is concept builder. This is concept builder. Yes. Here log 216 base root 6. Root 6. Square root of anything can be written as what? A raised to 1 upon 2. Yeah, nth root. This is property of indices. Nth root of anything can be written as what? A raised to 1 upon n. Yeah. Okay. So here first I will simplify this power of the base, which is what? Log of 216, and here I have 6 raised to 1 by 2. Is it visible to you? 6 raised to 1 by 2. Fine. Now we know the property of log, the rule of log, which is what? Log of m base a raised to b. Log of m base a raised to b can be written as what? Log of m base a divided by b. Remember, when you have power of this number, then that will come as multiplication, but when you have power of the base, that will come as division, right? So I will use this property here. So that way it will become log of 216 base 6, and this power of the base will come as denominator 1 by 2. Clear? Okay. Now simplify further. How do you, what power of 6 can get you 216? Yeah, we have done this in the previous question. 6 cube 216 you can get by 6 cube. So this value can be written as 3. Yeah, 6 to the power 3 is 216, and denominator 1 by 2 as it is. Now denominator will come in numerator. So 2 will come in numerator. That will become 2 3s are 6. So that is the answer. Yes. Okay. Yes. Next question. Yeah. Let's simplify this. So when you have log of some number, you should start simplifying from the innermost log. Start simplifying from the innermost log. For example, here we have log 81 base 3. Now that can be written as what? You know, 3 raised to 4 is 81, right? 81 is 3 raised to 4. So what power of 3 can get you 81? What power of 3 can get you 81? That will be log of, if I simplify only this part, so this part will get you what? 4, correct? What power of 3 can get you 81? Power 4. And then here, this simplified this, is 4 and remaining as it is. What power of 2 can get you 4? 4 is what? 2 square? Yes. So this will be 2 directly, right? Did you understand this part? This is your answer. Concept builder videos. Concept builder lecture. Yes. Now here, which property are we going to apply here? When you get the base here and the base of log is same, yeah, then we can write this as directly m. Yes, but do you see that happening here? See this? Do you see that happening here? This is 216 and here base is 6. So first of all I need to make this value 6. How do we make this 6? We will write this as this 216 as 6 cube, right? And this log of 49 base 6 as it is. Yeah. Now there is one property of indices, if you know, a to the power n bracket power m. Power bracket power, here a number bracket power, that in that case power get multiplied. Power gets multiplied. So n is multiplied with m. Yeah, this is property of indices which we are going to apply here. So here it will get you 6 to the power 3 into log of 49 base 6. Are you clear with this? Yeah. Now I will apply one property of log in reverse. Which one? That is n log m base a. If anything is in multiplication of log and if I want to take it inside the log, then it will go as power of this number. So log of m to the power n base a. That's how it will look like. Okay. Next, how do you simplify this? So now here I don't want this 3 because the property here, the log property here, you don't have anything in multiplication of log, right? Everything should be inside the log. So inside the log, if I want to take this inside the log, this should be 6 log 49 to the power 3. 3 will go as the power of this number, yeah, and base as it is 6. Are you clear with this? Yes, no. 49 cube, whatever it is, keep it as it is. Now are you able to compare this term with this property of log, that the base here and the base of log is same? So this m will be the outcome directly, right? So here what is the outcome? This number and this base is same, so the outcome will be what? 49 cube. Did you understand? Now you can see in the option, if it is directly 49 cube, that's fine. If not, then you need to simplify this and then match with the options. Okay, fine. Look at the next question. Look at the next question. See, anything which you want to note down, and I'm skipping that and I'm going to the next question or next step. You can pause this video and then note. I hope you are making your own handwritten notes. Okay, this now. Here the innermost, this is what we need to find. This is what you need to find. Now when it was given, we started solving from inside. When we need to find this inside value, then we start solving from the outermost log. Should I repeat this? When we wanted to find the total outcome of this expression and the innermost value is given, then we start solving from the innermost one. But in this case, the innermost one you need to find out. So you start solving from the outermost one, right? So which will apply the principle of log, that is what? Log b base a equal to x. In that case, a to the power x equal to b. Yeah. So here we will, let me write this question again. This is log of x, and here it is base 2, here base 3, and here base 5, and here we got 5. Now keep this as it is, okay, and apply the property of the principle of log in the outermost one. So here I can say 5 to the power 1 equal to whatever is inside the log. Can we say that? Look at this principle once again. Yes. So here 5 raised to 1, and here what you get? Log base 3, and here log x base 2. Now I'll do the same with this log now, where I will take this 3 raised to 5 equal to the value inside it. So the value inside it is what? Log of x base 2, and here 3 raised to 5. This will get you what? 3 raised to 5. Did you understand this? Yes, no? Yeah? Simplify it further. What do you get here? X. You want to simplify this 3 raised to 5, you can. 3 raised to 5 is 81 into 3, that is 243. Okay. Now you will simplify this. Again, apply the principle of log. So it's 2 raised to 243 equal to what? X. So x is equal to 2 raised to 243. And this is what you get as the value of x, which we need to find out in the question. Yes. So these are some basic questions on log with the properties and principle of log. I hope you understood this part. If not, then I suggest to revise this again. If it is something new and strange to you, do it again. And if it is still not easy to understand, then please make a comment on the comment box and let me know. We can do that. We can simplify it further. Yeah, I can try making it easier, although this is quite easy. Yeah. I hope you will understand. Yes, all my students are intelligent. I know that. Okay. So this is it in today's lecture. My name is Shyam Manavat signing off. I will see you in the next lecture. Till then, stay happy, stay healthy, and keep learning. Bye bye.